You guys should have your spiral close. We're going to go to it a couple times today. Remember, 0 periods in the morning. I'll be here. I'll try to be here until about 4 today. I'm not going to stick around for long. For your sake and for mine. Those of you who aren't feeling well, you understand. Stay away from people, too, as much as possible. Those of you that are feeling fine, take your vitamins. Okay, hand sanitizer. All the above. Here we go. Section 1.4. I know a lot of you, at different points, might have gotten a little stuck in homework. Hold on. What is section 1.4 supposed to be about? Continuity and one-sided limits. Okay? How many things need to be true for a function to be continuous? 3. The point has to be there. A point has to be there. You have to be able to plug in an x value and it works. Or on a graph, there has to be a filled-in circle for every x value to be continuous everywhere. The point has to exist. What else has to exist? The limit has to exist, and then they have to agree. And for a limit to exist, the one-sided limits have to agree. Now, real quick, if you guys didn't notice, on Thursday, not Friday, I guess Thursday, on Thursday, I actually put little brackets or braces around which definition would be good to think about for algebraic examples like equations or graph examples where you're looking at graphs. And I'm actually going to add to this one. It's not in the forever card, but just like as a little clue, the bottom one, the bottom version of the definition is really good for piecewise functions as well, graphs and piecewise functions, okay? Then we went ahead and we talked about removable versus non-removable. We had to make a little change because actually jumps are removable as well. This is just one little problem that you need to fill in. We talked about what kinds of functions are continuous everywhere, we'll never have to worry about. And even if we divide or add or multiply, as long as they're both continuous everywhere, we're still good. We talked about a few different functions and the continuity of each, which was like homework. We talked about piecewise. Why are piecewise functions tricky? Or I should ask, when are piecewise functions tricky? When x is not approaching, or when x is approaching, I should say, when it is tricky. Uh-oh. You guys can't tell by looking at the page? Separator is key. If x is not approaching a separator, no big deal. Just plug it into the right spot. This one, x was approaching 1. How did I know to plug it into the E one? Because 1 is greater than or equal to 0. So I established the piece that was proper, and I plugged it in, and I was done. Okay? What was different about the second example?
It's approaching a separator.
It's approaching a separator. And can someone, because I actually had this question about 3 different times over the weekend, which was fine. I loved answering it. But can someone in your own words describe, what do I mean by separator? That was the question I got over and over again. What do I mean by separator?
Where one of the pieces ends and another one picks up.
Exactly. Where one piece ends and another one picks up. It has to be actually written. The number will be written. This is the easiest way I can say. The number will be written in the inequalities. So -2 on one side is one piece, on the other side is the other piece. And if you're thinking about it, -2 below less than, use the less than piece. And -2 above, use the greater than piece. And how do we find the limits of these pieces? What did I still do? Can you tell? I plugged it in to the greater than piece, and I, kind of plugged it in. Can you plug into a constant? Nope, you stayed the same. And then I compared and said, hey, they're the same thing. Hence, that was weird. The limit exists. The limit exists, okay? That's what we were doing on Thursday. We got right up to here, and we stopped. But kiddos, why did I stop? First of all, what am I doing? Making it continuous. I'm making it continuous. Now, how am I making it continuous? I'm saying, well, to be continuous, polynomial, you're great. Polynomial, you're great. Separator, I don't know. I gotta make you great. How do I make them great? I come from below or less than -1 and plug in. I come from above or greater than -1. I plug in. What about f of -1? It was the same as greater than, so it didn't matter. They're the same thing. So I went ahead and plugged in. And my question at the very end of Thursday, I think around when the bell was going to ring, was, oh my goodness, how on earth do we solve? Oh wait, the only unknown is who? So all we have to do is a little bit of algebra, right? 4 minus 1 equals, you guys should be in your notes, a plus 1. This was the last example that we had in our notes. Technically, over the weekend, you were supposed to copy down the next 2 pages. I'm just going to make sure that we have no questions before doing an example like homework and then checking the evens. 4 minus 1 is 3. 3 take away 1 is 2. A should be equal to 2. This is a very, very good AP question. AKA, they love the whole make it continuous example thingamabob. I think that's right. To make it consistent. Okay. Before we go away from this page, this should have been in homework somewhere. Okay? Did you guys have any questions about what I did, why I did, how I did for this type of example? Yeah.
Why did you solve A?
First of all, he was the only unknown, and second of all, that's what they told me to do.
Oh,
Does that make sense?
oh.
But I think in homework, was it K, A, C, M? They use all different letters, do you remember?
It was A.
Oh, it was A.
It was A and B.
Oh, that works. If it says A and B, there might have been a little baby system of equations, which might have made it a little harder. We'll peek at that when we go over homework questions in a second. Okay. This is a page that theoretically you should have written down over the weekend if you didn't. You might want to figure out how much space to leave, because I'm not going to take a long time on it. There was one homework question that coincided. And believe me, guys, I choose the homework questions, so it's not like I'm teaching you the homework questions. I made homework questions based on what I thought was important, just in case you ever wonder that. If I was to give you a function like, those of you guys that copied this down, what was the one I used in period 6? 36. 36? 46? 64. Okay. It doesn't really matter, it just makes a different circle. If there's a 64 and you're like, circle? How is that a circle? Square both sides and move the x squared over. It's a circle with a radius of 8. 8. -8. Okay. It's a semicircle technically because, pretend that's a semicircle. It's only a positive square root. A negative square root would give us the bottom of the semicircle. Here's the idea. I can say this function, which only exists between -8 and 8, and if you were to think about the domain and how that has to always stay positive, if I plugged in 9, that'd be a negative, or -9, that'd be a negative. I can say this function is continuous on the closed interval, -8 to 8. I can make that statement because of this little theorem, I suppose, probably is, as to what it means to be continuous on a closed interval. And some of you, just a few of you, might be like, that doesn't make sense because you can't come from the other side of -8, and that's okay. If -8 is the beginning of an interval, I can say I'm only worried about as I approach from the right. I don't have to worry about the left. And if 8 ends the interval, I can say I'm only worried about approaching from the right, not the left. So just a few of you are like, but it doesn't exist at -8. There is a quick little clarification that says, no. If you're talking about a closed interval, you will just come from the one proper direction. It does not have to come from both. And it's not really worth spending much more time, but any quick questions on this one, Brandon?
Why does it say from A negative and A positive?
Oh, thank you. Which one's the right one?
It would be B negative.
A is the continuous, A is on the left, so I'm coming left from the right, which A positive is great. And then B, that's a typo. Good catch, buddy. B is the other endpoint, which would be over here, and I'm only coming from below. So B, I'm coming from below, and A, I'm coming from above. Nice, no one really takes contact. Okay. All better. They weren't paying attention? Maybe. Okay, and then the last thing was, and this is why I'm taking a second, IDT. First of all, those of you who copied this down already, what was missing that I had to fill in? Maybe you didn't watch the video. Did you guys just write it down? It was a little element. It was a little because they weren't showing up in the font that I had. Comic Sans doesn't really have math symbols. We're going to talk about this one more as it applies to actual word problems. However, if you were wondering why we didn't have a forever quiz today, I haven't talked about it. I didn't tell you to get out a half sheet of paper, etc., etc., etc. It's because we hadn't technically gone over our very last forever card that was going to be on the quiz, which is forever number 5, which is IVT. Oh, stink. How much did I box in period 6? Did I box the purpose?
You boxed
I didn't, right?
You just boxed the yeah. The
Perfect.
blue.
Thank you. Okay. If f is continuous. So f has to be continuous for this thing to apply? Yep, that's important. If f is continuous on the closed interval, and if k, wait a minute, what kinds of values are the f of ones? Are those x's or are those y's? Those are y's, so k must be a y value too. Huh. So as long as a function is continuous on the closed interval a to b, and if there's a certain y value in between the two y values of the endpoints, there exists at least one number, that's an x value, such that the function at that x value maps to the y value. Now what on earth does that actually mean? And I think I actually moved, did I move him down? I think I did. I think I made 1b here. There's a. And a has a point, and the point goes with the y value. So a and f of a go with 1 point. And then b and, let me use this one. B has its own y value, f of b. Here's the long story short. If this is all you had, just 2 points and their y values, that's not a 6, sorry, that's a b. And if you knew that f was continuous, here's my question. Why does there have to be a 0 somewhere in between a and b? It has to cross the x-axis. If you're going to connect these two without picking up your pencil, what's it going to have to go through? Now, how many times could it go through? Connect it. Shortest distance between 2 points is a straight line. That's one way it could go, and it could hit right there. Or couldn't it be like a parabolic thingamabob and it would hit way over here? Or it could be a down or an upward parabola and hit over here. Or it could be some sort of funny oscillating thingamabob. It could hit like 1,000,000 times, right? If it was oscillating really strange. So here's the long story short. Can you tell me for sure how many? You can tell me. Guaranteed at least once. Now here's another question. What if I was to ask you about this one? He's not a 0. But is there going to have to be some c or some x value that also is going to hit through this height as well? Yeah. Why? Exact same reason. And didn't we talk about this, or you wrote something down in your summer packet, and I had you say, what's the first letter of intermediate? And then the first letter of value, and the first letter of theorem. And you're like, that was dumb. Yeah, but it's because we're going to call IVT for the rest of the year, and hopefully we remember it. So IVT, intermediate. Intermediate, think in between. There's guaranteed to hit at least once. In between A and B. Each of the y values in between f of A and f of B. We'll talk about it more. Last year I think I did the whole, and this is, we talked about it in pre-cal. But I think I did the whole, like, hey, when I was born I was, I don't remember how many inches, but something, a lot smaller than I am now. So let's say at one point I used to be 2 feet. That wasn't when I was born. But at one point I used to be 2 feet tall. And now I'm 6'2". Was even I at 1 point 4 feet? Yes. How about 5'2"? No, 5'2". How about 5'10"? 5'11"? 6'4". Why? Growth is continuous. I had to go through all of those, and not just continuous in the sense of it's not infinite. I'm done. Praise the Lord. I might start shrinking, but my dad did. But growth is continuous, so I had to go through all the in-betweens, intermediate values there, and we'll talk about it more. But what on earth did homework ask you to do? And this is, I think, what no one got to even did the notes over the weekend. What are they giving me? Well, what's first? A function. What's second? An interval, A and B, right? So first a function, second an interval, and third a value. And they're saying verify the intermediate value theorem applies and find the value C guaranteed by the theorem. I think I gave you guys 99 in homework, right?
And 102. And 102.
Oh, and yeah, there's more. Why did I give you 99? He's pink. And what was it for the problem? A QR code. And what does that mean if you scan a QR code with your app, or if you just go online to CalcView? What is there a video solving? Hey, some of you need to learn how to use your textbook wisely. Okay, let's look at number 100 though. Oh, we can look at 99. We're going to check our homework anyway. Get out your spirals, open it up. But if you want to stay in your notes and do it because you're like, I didn't quite get there, then you can stay in your notes and keep doing it with me. Verify the intermediate value theorem applies. Okay. According to the theorem, the function has to be, what was number 99? Is the function for 99 continuous? How do you know? Because he's a polynomial. All polynomials are continuous. Okay, so that's the if. But then, after the if, I have to say, okay, I'm guaranteed every single y value in between 0 and 5? No. 11 doesn't have to be in between 0 and 5. These are x values. What do I need to find to figure out whether or not 11 is guaranteed? I need y values. So I need f of 0, and I need f of 5. I need f of b, and I need f of a. I need to figure out, does 11 fall in between? If it does, sweet, it's guaranteed. If it doesn't, I know nothing. So f of 0, what'd you guys find when you plugged in? -1. F of 5, what'd you guys find when you plugged in? 29. The question, is f of c guaranteed?
Yes.
Mm-hmm. So f of c equals 11. Must be a function value. If I was to actually write it out, for at least 1, that's all I can say, c within 0 to 5. Has to hit at least once. Might hit it a million times, but it has to hit at least once. Ellen.
For this one, I could have just set it equal to 11, and then I found 3.
That's great, unless it's like a function that's way too complicated, or what if they don't even give me a function, they give me a table of values, then it gets really tricky. But technically that helped you, hopefully, in the sense of you were able to find the x. And that's actually what they asked us to end with. But in order to figure out that the theorem applies, this is all, it applies, it applies, it applies. And then it says, okay, go ahead and find C. So then to find C, all we have to do is set the whole thing equal to 11, right? Set the whole thing equal to 11, we move it to the other side, so we end up with minus 12 equals 0, is that right? And then we go ahead and do our factors. And we get x plus 4, x minus 3. So we have x equals -4 and 3. Wait a minute. Which one fulfills the guarantee that it's going to hit at least 1 between 0 and 5? At least 1. Yeah, -4 doesn't work, right? He's not in the interval, but 3 does. But 3 does. Does that maybe help for number 102? If you guys didn't, go see the online solution workout. All right, I think that's the end. Let's go check some evens, okay? Some of you are ready for this, some of you are not. Nice thing is I'm taping it. I'm taping it, which means if you weren't completely ready with homework today because it was a 4-day weekend, it was hard. What can you still do on your own time? What did I say, 4? There we go. All right, we have 4, 18, 32, 38. We'll start there. Number 4. Oh, yeah, it's probably. Number 4, ABC. Are we good? The limit from one side is 3. Limit from the other side is 3. The limit is 3. Wait a minute. Why was it not continuous?
Because F of 3 doesn't
The point didn't exist. Alright, number next one is number 18.
Yes.
Danny, 4K. They don't agree. 18, the limit does not exist. Why? The one-sided limits do not agree. Number next one. Oh, no.
32.
Can I ask a question about 13?
Real quick, can't promise all full answer. Go ahead.
Okay, because I think we did it in class once, but we got DNE.
DNE is if there's no little sign, because coming from each direction disagrees, but if you're only coming from one direction, sorry. If you're only coming from one direction, it's gonna be the limit. If you're coming only from that side, does that make sense? If you take away that little minus, it would not exist. Since it only has to come from one side, you can say what it's going to be. Sorry, what was past number 18?
32.
Oh no, it's discontinuous at 1. 4K. Coming from below 1, it should be 1. Coming from above 1, it should be 1. But at 1, it's 2. That doesn't agree. The limit was 1. The two sides did agree, but the point was not where it was supposed to be. Number next one.
38.
38. Now, if I'm going too fast, you can just watch the video. Slow me down. Non-removable. Porquay. Pourquoi and pourquay together. I'm not discriminating between our two foreign languages on campus. Non-removable discontinuity. Why? Can't factor. That's a vertical asymptote. That's not removable. Number next one.
48.
48. He's right here. Negative 1/5. What? Non-removable at 3 because you can't cancel at 3. But removable at negative 2 because you can factor that puppy out. You can factor that puppy out. Long story short, his limit is a constant, it's removable. This one up here, the limit is a vertical asymptote. So 3 is non-removable, negative 2 removable. Number next one.
54.
Why did they say possible at 2? Because he's a separator, right? The point should be at negative 4. Coming from below is negative 4. Coming from above is, so the limit does not exist, therefore, non-removable discontinuity. It's not just a hole. We have them not making up. That's a jump. No, sorry, that's a break. Remember next one?
66.
66. We should be close at this point, right? A is 4. A is 4. Long story short, factor, cancel out, plug it in, plug it in. 2A, we need 2A to do 8, so A is 4. And number, next one?
102.
Oh my goodness. Okay, long story short, function is continuous on this interval. Did anybody get stuck about 1? It's not continuous at 1, but it's 1 in between 2.5 and 4. That's not a problem. So f is continuous here. 1 is outside the interval. We check the y values. Did 6 fall in between? Yes, it applies. Check. So then set the whole function equal to 6. Solve. 2 doesn't work. He's not there. But 3 is in between. Check. C equals 3. Do I have any more?
No.
Any more easy? So with that, kiddos, you guys can check the odds. Remember, please ask myself, ask someone else if there is an odd in particular that you are stuck on. We have 0 period, we have after school. And it could be as the test draws nearer. As the test draws near, you might want to get those questions answered. Yeah. I think it's Friday, unless 1.5 or 1.6 takes longer, then it might be.
I love life.
See, Monday's a chapel day.
Yeah.
Tell us no. Just kidding. You can beg. Sometimes she actually does. Is that regular number 18? All right, hold on. since some of you guys just got really freaked out, let me show you real quick what 1.5 and 1.6 is on. Because that's the two new things. We're going to do one today, one tomorrow. Big old review on Thursday. Okay, let me show you what 1.5 and 1.6 are on. 1.5 is just on this. What if you plug in and you get number over 0? That's all of 1.5. How do you deal with number over 0? Okay, all of 1.5, infinite limits, number over 0. How do you deal? We're going to do graphically, numerically, algebraically. Look, guys, look at the next 1, 2, 3, done. Okay, what's 1.6? Horizontal asymptotic trace. Degree test, done. Okay, that's all we have left. Both things that you did in the summer packet, especially 1.6. So that's why I'm thinking test on Friday with still giving us lots of time to review. All right, we'll see how we do. If something causes you guys major problems, we'll try to figure life out. However, I think between 1.5 and 1.6 will be good. So some of you guys need to catch up a little bit right now. Technically should have caught up over the weekend. But I think we have this. Now, let me give you a choice since you don't have a choice on the test. Let me give you a choice on the forever quiz. Okay? There are no new forevers in 1.5 or 1.6. Maybe there should be, but there's not. So since there are no new forevers, at least none that we really need to know for a quiz, I was planning on having it on your calendar. I'm having a forever quiz tomorrow. However, if you guys are like, I'd rather have an extra day, have it the day before the test on Thursday. We can do Thursday too. We'll just cut it to review. So we can do it tomorrow. I don't think 1.6 is going to take us a long time, so we have plenty of time for both. Or we can do it Thursday, have it cut into our review, but you have an extra day to study. We're just going to vote. You guys choose for period 1 and 6. So think about it. Tomorrow, less time to study, but then we have it done with more time to review. Or Thursday, less time to review, but more time to study. Does that make sense? Okay, who wants tomorrow? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Who wants Thursday? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. Okay. But the nice thing, those of you that voted for tomorrow with the review, we'll try to finish 1.6 early and then start review tomorrow. Sound good? Then that way we'll hopefully not miss out. All right, here we go. We'll start reviewing tomorrow. 1.5. Here we go. Have we already written this in our notes?
No.
Okay. We're writing right now, new section, new set. But have we already written vertical asymptotes, number over 0, infinite form in our notes? Yes. So technically nothing new. We're just going to expand. I told you guys back in section 1.3, number over 0 is a vertical asymptote. We'll get back to it. We have a whole section to get back to it. Okay. So with plugging in, we know we take a limit. We know that we plug it in. We know that there's a 0 on the bottom. Oh no, keep going. No. Only keep going if there's a 0 on top as well. If, when we plug in, limit as x approaches c of f of x, if I plug in and get 0, number over 0, any number, any constant, negative, positive, rational, irrational, it could be pi over 0. I don't care. There is going to be, I can state, a vertical asymptote at x equals c. That is my conclusion. Okay? But back when we first wrote this in our notes, do you remember that there were 3 different ways that we could have a vertical asymptote? Technically 4, but 3 different main ways at c. We can either have the function agreeing as I come from below and above c, and going to positive infinity would be my answer. Or I could have the function agreeing and going down. What would be my answer? Negative infinity. Or I could have my function disagree. As soon as my function disagrees, the two-sided limit, remember the normal one, with no one side or the other, is going to not exist. True? But since that time, we can also talk about one-sided limits. So then looking at this, guys, if I just took a one-sided, shouldn't I be able to say infinity, infinity, hey, two-sided infinity? Coming from the left, negative infinity, from the right, negative infinity, hey, negative infinity. From the left, positive infinity, from the right, negative infinity, oh, dear. Now I want you guys, if the graphing calculator is close, or if at least one graphing calculator is close per group, quickly graph 3 over x minus 2. Sketch the graph, and from that tell me the limit as x approaches. You're graphing the function 3 over x minus 2. I'm trying to think of as I come from below, as I come from above, and then as I come towards both sides. Okay, leave your graph, go fast, short around to your group, go fast. I'm trying to answer the question as I come from the left, as I come from the right, and then the limit in general. No, this stays exactly, it's just this is telling you only from the left. But everything else. Does that make sense, Christian? Do you guys get it's the basic graph shifted 2 to the right and then stretched a little bit? Maybe that's too much. Transformations, that was pre-count. As you come from the left, where was he going? He was going down. As you come from the right, where was he going? Positive infinity. Okay, so what's the two-sided limit? D and Now, how many of you guys are like, I get why it's D and E? How many of you guys are writing so you're not participating? Okay, that's the rest. But why was it so easy? Because you were given a graph. You were given a function, but then I let you find a graph. State how many different ways we need to deal with math. Problem solving 3 and analyzing 4. Analyzing we have to go into the verbally. But just for quick problem solving of like multiple choice, graphically, numerically, or algebraically, we're given data. So this one says, hey, you're given a graph. Now guys, you know the answer, it's D and E. Guess what? I'm going to use the exact same example for the next 2 ways of analyzing. But the next question is, what if we don't have a graph? You can summarize. I say, what if no graph? How do we do it without a graph? And some of you are like, we freak out and run out of them.
Yeah.
So let's say, what if we have a table? Well, if we can make a table, and they're like, I can't make a table if I don't have a graph. Well, hold on. We're building up to the what if we don't have our calculators at all step. We're making baby steps. So what if no graph? And here's my quick way of summarizing. Numerically, how do you do it? You figure out a function from the table will either increase without bound or decrease without bound while approaching its vertical asymptote. If it increases without bound, that's infinity, right? Positive infinity. If it decreases without bound, what's that going to be? Negative infinity. Does this table look weird at all, or is it kind of like, no, we've done stuff like this before? Yeah, x is approaching 2, because that's my vertical asymptote. So I'm going to approach from the left and from the right. From the left, I could do what? 1.9, 1.99, 1.999? Is that okay? From the right, I could do 2.1, 2.01, 2.001. Now, you guys, at least one per group has this in your graphing calculator. You guys know videos. Go to your table. Someone get me 1.9. Corey, you have it? What do you got? It's a negative, and it's a weird big number. Negative 30. Someone get me 1.99. Negative 3. What? It's decreasing. Hey, that's a clue. Next one. Oh my goodness. What seems to be happening as you come from the left?
It's approaching
I don't, oh, yeah,
infinity.
Is that okay?
Approaching negative.
Negative infinity, right? It's decreasing without bounds. So I can say coming from the left, sure seems to be approaching negative infinity, right? And this is technically as x approaches 2 from below. My f of x, I'm just showing a quick summary. Okay, now, x approaching 2 from above. 2.1, who's got it? 30. 2.01.
300.
2.001.
3,000.
Oh my goodness, I think it's increasing. True, and if it's increasing, what are we going to say f of x is doing? Approaching positive infinity. And say, okay, I get what this is doing. It's getting bigger and bigger negative and bigger positive. So therefore, this one's going to negative, that one's going to positive. Can't we from that also be able to say the limit does not exist? And not just say how it does not exist, but don't we have an idea at 2 of what my graph is doing? Just from the table? Give a couple seconds. So from a graph, yes, you can look at it and see. From the table, yes, you can look at it and see. Okay, but hold on. On this page, I took away the graph. What am I going to take away on the next page? The graph or the table. I'm going to take away the calculator. So hold on. Look here. I want you guys to think. Did the numbers really make the difference, or did the sign? Did the numbers really make the difference, or did the sign? If I know it's a vertical asymptote, don't I know it has to approach one or the other? Maybe they'll agree, maybe they'll disagree, but I know it has to be either going up without bound or going down without bound. How can I tell the difference? Negatives or positives? Now guys, we plugged in 6 different points. That takes forever. So if we needed to visualize plugging in like a table, but without a table, we're going to cheat and we're going to zoom in right here. And we're going to ask ourselves, does it have a negative or does it have a positive? And then we'll be done. Does it have a negative? It's approaching negative infinity. Does it have a positive? We're approaching positive infinity. So let me show you how we'll do it without a graph or a table. Yes, I know it's the exact same problem. Yes, I know you already know what the answer is. But yes, I know you're seeing it 3 different ways. So basically, what if no graph or table? AKA, no calculator. Pretend plugging in from the left. Oh, I guess we're using A's more, aren't we, nowadays? There we go. Pretend plugging in from the left and from the right. Just one. Just one value each. I'm not doing the whole like 6 total, 3 each. I'm not going to do that without a calculator. You kidding me? I don't want to torture you guys. Pretend plugging in from the left and from the right, checking the sign. As you guys are writing to catch up, let me show you what I mean down below. I should do this. You can keep that. I'm actually just adding. I know. Sorry, Ethan. I'm showing like before we do anything. We plug in, we get 3 over 0. We know it's a vertical asymptote. Then we say, okay, let's come from below. Let's come from above. Come from below, we could pretend plugging in 1.9. come from above, we could pretend plug in 2.1. You don't need to find a number. You just need to tell me a sign. We know it's infinite. What kind? Guys, 1.9 minus 2, who wins? Yeah, the negative wins. So since it's negative, I'm going to say negative infinity. Now this is kind of like pretend math, but it tells us all we need to know. So limit is negative infinity. But the bottom one, 2.1 minus 2, what's that going to be? Positive. Guess where that one's going? And then we can look at this and say, hey, it's a vertical asymptote. True, but what's my overall limit? They don't agree because it does not exist. Did I find any numbers? Nope, I don't care. I was only checking the sign. So, what if I was to give you something like, for an example, this is the last one, the limit as x approaches 5 of negative 1 over x squared minus 25. No calculator. What would you do?
Like a 5.1.
Well, first of all, hold on. First of all, plug in 5 and you get what? Number over 0, vertical asymptote. Now we say, uh-oh. Let's come from below 5. And let's come from, bless you, above 5. Pretend plugging in what?
5.1. 4.9.
Oh, below. Now hold on, this is harder. I don't know what 4.9 squared is, but I know it must be less than 25. What's my sign? Negative over a negative. Uh-oh, that's going to be a positive. And then I'm going to have 5.1. Hold on. It's going to be bigger, right? So I'm going to have a negative over a positive, which is going to be a negative. What's my limit? Kiddos, 1-5 due tomorrow, but you have today after school and 0 period to come ask me questions.
What's the forever quiz on?
I need to make sure.
We actually have to memorize all of it.
Forever quiz, everyone voted for Thursday, so tomorrow we're gonna do 1-5 questions, 1-6 hard.
Wait, what's the forever quiz?
Parts 1 through 5, it's on the PowerPoint on
Can
Monday.
you just memorize them?
Oh my goodness.
Graded?
Yeah, kind of.
Alan.
Yeah.